So now we're looking at the analysis. Remember at the start we're looking at linear searches, and I said if you've got an array of n items, your linear search would be on average n divided by 2. So your search would be n divided by 2. So 100 items would on average, it would take 50 passes to find a goal in a linear search. With binary search, we know that we have to list every time to try and make it more efficient. And on average, our search length is the log of n, okay? So if you've got 64 items, the average search length is 6. Now, you don't really have to remember this, but it's good to have something on hand so you can compare. But if you've got a linear search array of 64 items, we know that our average search length will be 32. So you can see that it's a huge gain in using a binary search. There is a problem though, and the problem is when you've got really large arrays, okay? If you've got something where you take the low and the high values and they can exceed the storage limit for an integer, then it's going to cause something called an overflow, and this will crash your program and possibly your computer as well. So there's a slight adaptation to the midpoint calculation. So instead of adding it together, you take low away from high first. So it's like the difference is left over, and then you add the difference to low and divide it by 2, and that avoids any overflow. Okay, but either of these methods will be fine for the stuff that you do for your projects and the stuff that you write about for your SQA exams. Okay, and to finish, here is a comparison of linear search from higher and binary search. So linear search, very simple to code and implement. Okay, binary search, a little bit more complex. It's got an if statement instead of a conditional loop. Linear search is quite efficient if you've got very small lists. Okay, so 10 items. Linear search, very efficient. Okay, binary search, much more efficient for any length of data lists. I would say that once you're getting to the lists of like 20, 30, binary search is much more efficient as long as it's been sorted first. Linear search is slow to find items in a large list because each item has got to be compared. Binary search much faster, because it halves the list. It cuts things in half very quickly. Linear search, however, advantages, doesn't have to be sorted. Binary search does. We talked about the average search length already there. And another advantage of linear search is that it's kind of part of other standard algorithms. So finding max, finding min, and also in a selection sort, which is one of your other lessons in advanced higher. Binary search is also something called a binary chop. And I've been doing that all the way through there because it kind of cuts your list in half. And that binary search is also used in fast sorting routines. However, you won't learn about any of these fast sorting routines at advanced higher. That could be something that you investigate as part of your advanced higher project and take your knowledge beyond advanced higher. Okay. Hope that all made sense. And if you've got any questions, just pop it into the chat or as a private comment. See you soon.